Section 4.6, Isosceles Triangles. The first part of your notes will include the properties of an isosceles triangle. Up here on the top of your page, you're going to have an isosceles triangle. Your two sides are going to be congruent. That create the vertex angle. Right? So the vertex angle formed by two congruent sides. Your two base angles, which are these two bottom ones, right, formed by the base and one congruent side. So this base angle is formed by this side and your base. So those are the properties of an isosceles triangle. The next thing that you guys need to know is the isosceles triangle theorem. It states that if two of the sides of a triangle are congruent, then the angles opposite those sides are congruent. So that makes sense with our figure above. If this side is congruent to that side, then this angle here and this angle here, that's across from our two congruent sides, are congruent. So your first proof that we're going to work on is example number 1. So let's just adjust. Alright, you have to write a two-column proof based on these triangles. So when we look at this figure, we look back at what the given information was. This given information says that AB is congruent to BD as well as BC. Right. They also tell us that this angle DCB and ACB are congruent to each other as well. Now, knowing that if we have two sides of a triangle are congruent, so looking at CBD, if those two, this side CB and BD are congruent to each other, we have an isosceles triangle. Same thing here. Alright. So let's look down at what they want us to prove. They want us to prove that this angle A and angle D are congruent to each other. Now, we know that these are both isosceles triangles. Since the sides are all the same length, the three that are supposed to be, the two sides of your isosceles triangle. And we know that whatever this angle is here, BCD and BCA, those are congruent to each other. Then we know that these are exactly the same thing, and that we can prove that angle A and angle D are congruent to each other. So let's take a look at my proof. All right. First thing I do is I just state the first thing that they gave us. Okay. Again, that's just saying that our sides AB is equal to CB is equal to CD. So it's given. Next part is I just rewrite that statement, but now I'm going to use definition of congruent segments to state that. AB is congruent to CB is congruent to CD. Okay. Next thing that I'm going to talk about is that I know that these two triangles are congruent because they have those properties of isosceles triangles, right? So they're going to be isosceles triangles, and then we're going to state that angle A is congruent to ACB. So you've got these two angles that are congruent because in an isosceles triangle, base angles are equal. Same thing with the other triangle. You have this angle up here and D. Those are congruent to each other. Next step is we're going to say that those two angles are congruent, so that ACB that we said over here is congruent to BCD, which is given. Using that, now we've got the transitive property. If A equals B and B equals C, then A and C equal each other. So that's how we get that particular proof. On the opposite side, we've got a few more examples to go through. Okay. And I'm going to try to kind of cover up my answer that I have up here. You have this triangle here, okay? And if you want to, you can even pause and try this yourself. But what ends up happening is you've got these two isosceles triangles. You have and you know that CB or CDB, I'm going to make sure that you guys can see this. CDE is 120 degrees, making the base angles of C and E congruent to each other, so each 30. Now looking down at this triangle down here, ACB, that 30 and C on either side is each going to be 30. So what I did is I took away that 30 from 180, got 150, and I know each of these base angles will be half of that, so 75. So that's how I got my choice of angle D. Alright, next one. And this one I'll cover up what I got for answers. Okay. So when you're looking at your figure, you're going to find that you have to name two congruent angles. Then you have to name two congruent segments. So what I'd like you guys to do right now is just take a moment, you can pause the video, and look at that figure and name two congruent angles and two congruent sides. Alright, so you should have paused it and have your answers written down. So here are my answers. I said that PML and PLM are congruent to each other, and that MP or PM, as I've written it down, and PL are congruent segments, just using properties of isosceles triangles. Alright, example number 4. For this one, I've got a lot written down on here. Alright, what ends up happening, this is an example from the book, you guys can't see this. Alright, there you go. Should be able to see that now. So they tell us equilateral triangle. As we know from earlier lessons, an equilateral triangle, all of our angles are going to be acute and they're going to be equal to 60. So I know that angle F is 60, angle G is 60, and that E, which is bisected by EH, alright, so it bisects the angle. So angle 1 and angle 2 are both 30 degrees. Alright. Next, let's look at what they ask us to do. They say, copy the figure, which I already did for you. And they say, draw EJ, so EJ bisects angle 2. So this angle that's 30 here is now going to be cut into two congruent angles, 15 and 15. So I know this is 15, this is 15. This triangle over here, right, if this is 15 and this is 60, I take away 75 from 105, and that would be angle EJG. And then this angle over here, HJE, is 75. So when they're looking down at part A, they ask for HEJ, so that angle, HEJ, okay, which is 15, and then they want to know EJH, and then that one is going to be 75. Okay. Your last one, EJG, as we talked about before, is 105. Okay. And that's just some of the math that I did out. I also solved for x up here, just knowing that this is 75 and 15, that adds up to 90 degrees. This angle here has to be 90, so 15x equals 90 degrees. Divide each side by 15, and you got x equals 6. That concludes this lesson.